Hello, this is week 2 video assignment and the day 2 video. So we're going to be looking at topics in the 2B module. We're not going to do as much as we did on the 2A video on this part. A lot of this I like to do together in class, but we are going to just touch on some of the big topics and kind of their definitions. So 2B1 covers mean, median, and mode. Two main measures of the center of a data set when we talk about what does someone mean by typical, what's typical for a set of data are the median and the mean. The mean sometimes people call the average. You'll hear that. Sometimes that can rub people the wrong way because average is kind of a way to talk about measures of central tendency in general. But a lot of people know the mean as the average. So the mean is the most common measure of the center. The word mean and average are often used interchangeably. There's two different types of mean when we're looking at a data set that we can talk about. The population mean is the average calculated from the entire group under the study. And that's used this Greek symbol mu, mu. That is how you would say, I'm talking about the population mean. You would write that symbol to someone to let them know that you had averaged all of the data for the entire group in the study. The sample mean, X bar, is the symbol for that. That is an average found from a sample. A sample is just a small part of your whole study. Usually you can't get the population mean because our studies are usually based on like all US, citizens or all females in, this age group. So when you have a large population, it's almost impossible to get the data set complete and get everyone's data and then take an average of it. So most of the time we do what we call a sample that is representative of our population. And so that X bar is the average from that sample. Now, how do we find the mean if we have just some data in front of us? What we do is we add all of the data values, and to find that sum, adding them up, we divide that sum by the total number of values in the set of data. So if you're taking, 20 students took a test, I could add up all their scores and then divide by 20 because there were 20 students who took the test. And then follow any directions on rounding. Now, the second measure of central tendency that we talk about is called the median. The median is the number in the middle when your data is ordered from least to greatest. Now, this in the middle part can get a little tricky because if you have an odd set of data, which means you have like say 7 or 9 items, something that has an odd number of items, then there is exactly one number in the middle. But if you have an even set of data, there's actually 2 numbers in the middle. So we have to have a special set of rules for those situations. So to find the median, you sort your data in order from smallest to largest. I usually do this before I even do the mean. If I'm going to have to find all 3, we're going to talk about mode as well. I just always just go ahead and put my data in order from smallest to largest. But you have to do it for the median. Determine the number of data values in the data set. So if you have an odd number of items, then your median will be exactly the one data value in the middle. So there'll be one data value in the middle of your set when you're from least to greatest. And then if you have 2 numbers in the middle, because you have an even set, so say I have 10 items, the item in the 5th and the 6th position in that list, both of those are in the middle. So the median would be what is halfway between those 2 values. To find that, you add those 2 numbers together and you divide by 2. Okay, so you kind of average the middle numbers. And then follow any rounding directions if necessary. The mode is one that's not used as much, but it is important to know what it is. It is the most frequent value in the data set. So if every data item only occurs once, then you're not going to have a mode. Okay. If there's one mode, that means that there was one item that occurred more frequently than all of the others. There can also be more than one mode. So as long as those 2 values have the same frequency and their frequency is greater than any other, frequency just means how many times they occur in our list. And then if you have a set with 2 modes, it does have a special name. It is actually called bimodal. So that is just a special definition. How do we find our mode of a data set? You're going to sort your data from smallest to largest. That's not required, but you have to do it for the median anyways. And it's actually helpful if you have large data sets so that you don't miscount how many repeating values you have. Determine the data values that occur the most often. And those are the mode. There could be multiple. Remember we said there could be none or there could be multiple ones. So those that occur the most are the mode. If there are no repeated data values in the data set, then there is no mode. Okay, so here's an example I have pre-worked out, and then we're going to do one together. Find the mean, median, and mode of the data. The data below are the daily high temperatures for the last 2 weeks in March in Indianapolis. So 72, 70, 64, 52, 48, 35, 28, 68, 52, and 64. So I first reordered my data set from least to greatest. And as I did that, I kind of mark them off so I know that I've got them all. So 28, then 35, didn't have any more 30s, so I went to 48, then 52. I had 2 of those, so I wanted to make sure I wrote both of them. Then I had 2 64s, a 68, a 70, and a 72. So that just helps me when I do that to visually see I got all the numbers. Also, you could just count how many you have and make sure you still have that many. Find the mean. So since I've already got it in order, I just typed them in order. So I added all of the numbers that I had in my list, dividing them by, I have 10 different values. So this is 553 divided by 10, or 55.3. So that would be my mean, my X bar. Find the median. Well, because this is an even set of values, there's 10 values. The 5th and 6th position, if you kind of think about drawing a line between those, there are 5 numbers to the left of this, 5 numbers to the right of this. So the middle is between these two. So we add them together and divide by 2 to find what is the value exactly halfway between 52 and 64. So that would be a 58. So the median, when you have an even set of data, may not be a value in the data set. It might be the value in between the 2 numbers if you have an even set. And then the mode. Well, there were 2 numbers that occurred more than the others. That was 52 and 64. They both occurred twice, so they both would be the mode. So this would be bimodal data because we have 2 modes. Okay, so let's try one together. So I'm going to first list these in order from least to greatest. The smallest number I see is 32. So I'm just going to rewrite them. I do have another 30. I have a 33. I don't have any more 30s. I have a 41. I have a 48. I have a 52 next in terms of least to greatest. I have 3 53s. So I need to make sure I write all 3 of those. 1, 2, 3. And then I have a 59. So that's all of my numbers. And I had 1, 2, 3, 4, 5, 6, 7, 8. I think I counted twice. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I still have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So our mean, or our X bar here, would be to add all of these up. Oh, and I didn't even tell you what these were. Let me read the problem after I write this out, because this one's a fascinating one. These were the number of shark bites in 2012 to 2020 in the US per year. So I guess there's a lot of sharks nibbling on people. So that is dividing by 9, because there were 9 different years that we collected the data for. So if we add this up, so we have 32 plus 33 plus 41 plus 48 plus 52 plus 53 plus 53 plus 53. There were 3 of those. Oops. That would have helped if I was actually using my numlock. Okay, put that back on. So 32 plus 33 plus 41 plus 48 plus 52 plus 53 plus 53 plus 53 plus 59. It's very rhythmic. And that is 424 over 9. Sometimes you just have to have fun with it. Makes it more enjoyable. And then we're going to divide by the 9. And I'm going to round this. They didn't give us rounding directions, so I'm going to round to the nearest 10. Because this one actually is a repeating decimal. So we could write the repeating bar, but most of the time they'll be rounding directions. So 47.1. So that's my mean. My median. There is 9 numbers, so there should be 1 number in the middle since it's an odd set. So if you count in kind of on each side as you go, like 1, 1, 2, 2, 3, 3, 4, 4, this number right here, 52, is dead in the middle. Equally split on each side, there are 4 items. So my median is 52. My mode this time is very obviously 53. It is the only number that had any repeating, and there were 3 of them. So, all right, so that takes care of 2B1. So 2B2 is on weighted averages. So we've talked about an average, right? The mean was just add up everything you have, divide by how many items there were. An average is a measure of the center of a data set. So we just learned that, You calculate the average by adding together all the data points and dividing by the total number of data points. Each number in this scenario counts equally in your calculation. No one is giving any more weight. So we're not saying like a final exam counts double. Like, so, you know, it's all kind of equal and split out with equal weights. But if you want to do a weighted average, some numbers might count more than others count, or they may carry more weight. So there's two types we're going to discuss, and we're going to do one example of each in this pre-video, and then we'll do a lot more in class together. So we will do two types of weighted averages, weighted by counts, which is how your GPA is done. It's weighted by counts. And then category percent, which is how our Math 123 grade is weighted. Lots of classes actually weight by percentages. You see that in our syllabus. It says homework is worth 10%, or exams are worth 30% per midterm and then 30% for the final. So when a category has a percent weight attached to it, we're doing a category percent, okay? I find both easiest to do by making the tables. I really do. Instead of using the long formula that you'll be shown in Newton, they do come up with a really long formula. If you like that and you want to use it, I'm okay with that. I'm not ever going to tell you you can't do it a way that Newton also teaches it. But you just really have to be cautious about order of operations when you enter that into your calculator. You don't want to get all the work right and then type it into the calculator wrong and get the wrong answer. So let's look at the weighted averages by counts. So we have a variety of items or data worth different values. The frequency of each value is the count. Instead of listing each data entry individually, data will be grouped by common values to save time and be more efficient in calculating our average. So how do we do it? Well, to do it using a table, you're going to make a column for the item name, the number of the items that we have, which is a count, and the item's value, and then the total item value, okay? Make a row for each different item. Multiply each item count by the value for the total item value. So we're going to be multiplying. So here with GPA, we have classes. So those are our like names. Credit hours is how much a course counts. So some classes have a higher weighting because they're more credit hours than other classes. So that's how it's a count, okay? You get a grade, which is a value. We have a 4.0 system at Ivy Tech, so you would get a value attached to a specific letter grade. And then the total category value is found by multiplying the number of credit hours times the value of the grade, okay? And then we'll divide the total value by total count. So that's going to be the sum of this category. So all of our classes, what were the values we actually earned for everything? And the way I like to explain this for GPA, if a class counts 3 credit hours, making a C in that class, if you think about this person's taking, let's see, 12 credit hours. Imagine if everything was 1 credit hour, if they were actually taking, they're not taking 12 separate classes, but if they were, we're saying this one class, this math class with a C, it's like getting a C on 3 of those classes. So that's that. So that carries a heavier weight than making, say, an A in 1 class, because that's only going to count for you 1 time in this calculation, okay? So how do we do it? Well, first of all, we need to change these to values so we can actually multiply them. You change all your grades to their values. So a C is a 2 point, B is worth 3 points. Up here's the list. A is 4, D is 1, and F is 0. So D is worth only 1. A is worth 4. Now, like I said, making a C in a math class that is 3 credit hours gives you a value of 6. 3 times 2. Okay? It's like making a C twice, essentially, for the calculation. So then 3 times 3 is going to be 9, because they had that B. This class was the one that's really going to hurt their GPA. They made a D, which is a very low value for that grade in terms of how it helps your GPA, but it counted 5 credit hours. So that's 5 times 1, which is 5. Just think about how that would change if they'd made a C. That'd be 5 times 2. They'd have 10 points going towards their total category value. So this one's really going to be the one that harms the most. If your highest credit hour, if you make a bad grade in that, it's going to pull your GPA down a lot worse than if you made like a D in the 1 credit hour class. I don't encourage you to make D's or F's in any of your classes. Try to make, C's and better so that everything can transfer. But that's kind of how that works. The heavier credit count, you want to have a good grade in that class, because think about the multiplication happening here. We're not getting many category value points from that, okay? And then 1 times 4 is going to be 4, okay? So we're going to add all these together. That's going to give us how many total category value points did the student earn for that semester. So that is what, 15 plus 5 is 20, so that's 24. They took, we said 12 credit hours. So we take the total grade value, which is that category value there, which we found to be 24, and we divide that by the total counts, which for us is our credits, which is 12. So this person would end up with a 2.0 or just 2, but a lot of times we'll put the point, GPA. So that's a C, borderline C, because 2 is exactly a C. So they're like 70. They're right there at the bottom, almost at a D status. All right, so let's look at what if we want to weight by percent weights. So in this situation, each category has a percentage weight. Category percentages must total up to 100%. So like in our class, if you look at the syllabus, if you look at all the different categories, homework, project, instructor choice, outcomes assessment, exams, all of those percentages add to 100%. So again, I like to do it with a table method. If you want to use the Newton method, which is a long formula, feel free. But this time we make our table just slightly different, just because we were dealing with percentages. So we have a table with categories, whatever those are called, like homework, quizzes, whatever. Category weights, that's where you take your percent and you're going to write it in decimal form. So if it's worth 10%, we're going to write 0.10. Category average. So this would be, if you're doing all of your homework, it's not just one homework grade. It's all of your homeworks added up for the whole semester, and we get the average of that. So do you have a 70% average on all your homework or an 80%? That's what that category average is. And then the room to calculate the category percentage points. This is the same thing we did before, where we had our counts times our values, except we're doing our percent as a decimal times our average. So the category weights times the category averages. And we call these percentage points because when we're multiplying these together, these weights as a decimal times the average of the category, we're going to be getting values that are going to help us sum up to our final grade. Okay, so these percentage points are going to add up to what are we going to get out of the total 100% for the class. All right, so Estefana's accounting class is easy to navigate with just 4 categories, making up her final grade. She has homework for 10%, quizzes for 25%, midterm exam for 30%, and a final for 35%. So notice I've already written those 4 categories. I've written the percentages down and already converted them to the decimal form, okay? These are from her grade book, and it was listed here as well. At the end of the semester, her category averages were 98% on homework, 82% on quizzes, 68% on midterm, and 74% on her final exam. We're going to calculate the final grade in this accounting course. So I've already started a little bit of this. So you'd multiply your decimal for the weight, so that percentage as a decimal, times the average for that category. So 0.1 times 98 is only 9.8 points. So the best you could do in homework, think about it, is if you had a category average of 100%, so all your homework was 100%, times 0.1, the most you can earn towards your final grade in homework is 10 points. So Estefana did pretty good. She got 9.8 points, percentage points out of, a possible 10. And same thing here, 25%, if you make 100% category average, the most you could get is 25 points. But she had an 82 average in that category. So 0.25 times 82 is she earned 20.5 points out of a possible 25 points towards her final grade. Then we have the 0.3 times the 68. I got that was 20.4 percentage points. Notice this is where something didn't go as good for Estefana, because 30%, if we had 100 on our midterm, we would have earned 30 points towards our grade. So she almost lost 10 points by having that D on the midterm. So she pretty much lost almost a whole letter grade possible towards her final grade. And then 35% is 0.35 times the 74. So not as bad as the midterm, a little bit better in terms of grade wise. maybe some things started clicking. And so this equaled 25.9 percentage points out of a possible 35. Because remember, if this was 100, 0.35 times 100 would have been 35 points. So again, almost lost a letter grade completely from this one as well. So if we add all these up, this is 76.6, and this is out of 1.00 if you kind of turn this into a decimal. So you could still think of this the same way we did the GPA, where we took the total value, and that when we multiplied everything out, we summed it together, and then we divided it by the total weights or counts. But if you divide 76.6 by the decimal form of 100%, you get 1. You're dividing by 1. So it's just when you're doing the percent ones, and everything's in decimal form for your percentages, for your weights, this is the final answer. So her grade for the semester is a C. So she got a 76.6% in her accounting class. Okay. Now, the only thing left on this video is just a little bit about what we're going to be doing in 2B3. I didn't put any notes on this on the video because I want to cover it together in class. I just want you to familiarize yourself with some of these formulas before you come into class on day 2 of week 2. So we have absolute change, relative change, and percent change. That should have said change. It's always fun when I proofread these. I don't catch any of my errors until I actually do it. So if you are going to have a starting or initial value and an ending value of a quantity, for example, enrollment at Ivy Tech, we could say at the beginning of the year, enrollment was 50,000 students. At the end of the year, it's 60,000. Okay, so that'd be like a starting and ending value for that quantity. The absolute change would be the final value minus the initial value, and we take the absolute value of that. In other words, just what was the change numerically? Like, did we increase or decrease by 10,000 people or what? Okay, so that's that absolute change. Relative change is the absolute change. So this number we just got here divided by the initial value. So and that's going to then give us a decimal that we can convert to a percentage. So we can times that by 100. There's supposed to be a percent symbol there to get percent change. So percent change is just the percent form of the relative change. Okay. Now I did put an example here, so I guess we will do it together. I thought I'd X'd it out, but it's okay. So a salary, so this is a real life kind of discussion. Your salary went from 20,600 to 31,000. So you got a raise. Find the absolute change, the relative change, and the percent change. Okay, so the absolute change. And Newton, they always report this as positive, so that's why we do the absolute value. But you could still say this was an increase because we went from a lower value to a higher value. But our final value is this one. And this was our starting value. So we would do 31,000 minus 20,600. We're going to take the absolute value of that, which just means distance from 0. So you report the positive of whatever number you get inside. Oops, not times. Sorry. Minus 20,600. That's 10,400. And that is in the same units. We don't usually put the units in unit, but that's in the same units that our original values were in. So we had an increase of our salary of $10,400. Okay. We do the relative change. We take the value we just got for the absolute change, so 10,400, and we always divide it from the old or the starting value. So we divide it by that. So that was our starting salary was 20,600. 10,400 divided by 20,600. And I'm going to round this to the nearest tenth of a percent. Well, not yet. I'm going to round it to 3 decimal places here because I usually round my percent change to the nearest tenth of a percent. But you might see 100th of a percent in Newton too, so just be wary. So I'm going to write that this is approximately 0.504. Let's go ahead and go 48 ... Okay. Now, the fun thing about percent change is we just multiply that by 100 or move it 2 places to the right and turn that into a a percentage, which is a little easier to talk about. So this would be moving that 2 places to the right and then rounding to the nearest 1/10 of a percent. That 4 would get bumped up by an 8. So that's a really good increase. So our increase for our salary went up by 50.5%. Okay. So like if you think about that, 20,600, and we times that by 0.505 and then add that back to it, you can see that does get us pretty close. Now we're off a little bit because we rounded. So yeah, this person did not get like a 2% raise. They got like a 50.5% increase on their salary. And that's probably maybe a position change. You know, usually that wouldn't happen in a year. Maybe they became a manager, or this, you know, or something like that. So this is kind of a bigger deal of what we're going to be doing in class. We're going to be doing a lot of variations on these problems and markups and discounts and things like that with percent increase and decrease. So I didn't want to get too heavy on it on the pre-video, just some formulas to be thinking about, and we'll talk more about that in class. I hope you enjoyed this video.